Okay, so finally, I'm
Okay,
going to show you two additional types of tests that we can run on our iOS apps in Xcode. Both of these tests we'll look at in the Angry Birds UI tests target, which we haven't touched yet so far. So if we take a look at Xcode, you see that we have three targets over in the Project Navigator. The first one, Angry Birds, is where our app lives. The second, Angry Birds Tests, is where the unit tests live that we've written so far. The third, Angry Birds UI Tests, is where we'll focus in this video, and you'll notice a file inside of it also called Angry Birds UI Tests. That file contains a class that inherits from XCTestCase, much like the unit test classes we've seen so far. It also has setup and teardown methods. The test example, though, in here looks a little different to the test examples we saw in our unit test cases. Whereas those were empty, this one has 2 lines of code in it. Let app equal XCUIApplication and app.launch. XCUIApplication provides us with a proxy application that we can start and stop. We use this to run tests in the simulator that allow us to simulate a user tapping on different areas or swiping or otherwise using our application so that we can write end-to-end tests from the UI end all the way to the back end to ensure that things are working all the way through in our application. These are also sometimes called feature tests, deep tests that test every aspect of implementing a feature path, like searching for data or scrolling through a list of items. So I'll tell you at the beginning, these tests have a reputation for being pretty flaky in iOS. The standard operating procedure when one of them fails is to run it again and see if it randomly passes. And so I wouldn't necessarily use a whole lot of tests like this in an application because they have a really low signal to noise ratio and also run rather slowly. But I want you to know how to make and read these tests in case you run across an iOS application that needs or uses them. So now I've put my cursor on line 31 below app.launch. And what I'm going to do is I'm going to write some lines of code that simulate a user tapping on things in my application. I could do this manually, but Xcode provides us with a feature that will record us tapping on our actual simulator. And you can access it through the red button that you see on the bar in between your code and your console right now on the left-hand side. It's a red dot, and when you hover over it, it says Record UI Test. We're going to click on that, and that gives us access to our simulator. Now, if I tap on items in my simulator, I get timestamped event matching error. Failed to find matching element. Let's try again. All right, it looks like it worked that time. So this is one of the reasons that this particular variety of test has kind of a rough reputation, is that things like that happen. You'll also notice that here on line 32, we have let app equals XCUIApplication, which says an error next to it, definition conflicts with the previous value, because we have that exact same line right here. And starting the simulator for testing reproduces this line, even though the default UI tests already have that line in it. We have to stop recording. So this little button in the lower left, we have to hit stop recording in order to be able to access our keyboard again. Okay, so now we have our application, which is launched, and we have a table, and we clicked on a cell containing the bluebird text and the he angry text, and then we tapped on it, and that took us to the detail page. Then we went up to the navigation bar in our detail view, and we found a button called Angry Birds, the back button, of course, and we tapped it. So this is the action that we went through, right? And if we were to continue to record here, we could do that. Like so. Stop recording. Get our let app equals XCUIApplication line out of there again. And so we can continue tapping through like this. Before we do anything else with this test, I can already see that there are some elements that are going to cause some flakiness in this test. The automated line includes cells containing the static text bluebird, and he angry. So this refers specifically to the data that appears in the first cell of our list. Now, if for some reason the bluebird were to be removed from the API and that were not to be on that first page of cells, this test would fail even if that has nothing to do with the feature that we're testing. So we might want to make this a little bit more robust. One way that we might do that is to say to tap on the first cell rather than to look for a cell containing this specific text. So I could say that with element bound by the index of 0. So now I'm going to be tapping on that first cell. Now, in between our actions here, we might want to include some assertions to ensure that our app is doing what we expect it to do. So for example, maybe I want to make sure that my Angry Birds back button is only on screen at certain times. So I might extract that into a variable, like so, and say, let Angry Birds back button equal that code that I extracted, right? So at this point, we want to make sure that that button exists. XCT assert true, Angry Birds back button exists. Beautiful. And then we're going to tap on it. And then after we tap on it, we want to be back at the table view, which should mean that that button doesn't exist anymore. So that might look like this. Except instead of asserting true, we're now going to assert false. Maybe after we tap on another cell, we want to assert that it's true again. And then after we tap back, we want to assert that it's false again. So this is an example of the type of assertion that you can include in a UI test like this. Let's run our test and see how it does. So now we're going to run it, and you can see the simulator going as we run it. Here it goes, back, tap, back, and our test passes. It's cool to watch when it works. The second type of test we wanted to learn about is the performance test. You see an example of it here on line 50 with the test launch performance method name. Inside of this test, you see this function measure, which takes a closure or a block. We can put any code that we want to in this block in order to ensure that it runs within a certain speed. In the example here, we see XCUIApplication.launch. Now, when I go to run this test, what it's going to do is it's going to run the code in that block 10 times. And as it runs the code in that block 10 times, it's going to time how long it takes on each occasion. You see here in the console that it's running now. This might take a second because launching the application is a non-trivial task and has to do it 10 times. You can see the amount of time that things are taking recorded here in the console. And as it continues to launch, it's recording the time for each one. At the end, it's going to give us information about the average amount of time that it took to run this code. Great. So it finished up, and now you'll see that next to the measure block, we have received a gray diamond near the line numbers. We're going to click on that diamond. What it's telling us is that this code took, on average, 1.84 seconds to run. Now we can use that information to determine how fast it might be acceptable for this code to run. So we can set a baseline that determines how fast this code has to run in order for this test to pass. I could edit my baseline, for example, to say 1.84 seconds is really too slow. I need 1.5 seconds or fewer in order for this code to be running fast enough. Now, of course, I haven't changed anything about the way that the app is launching right now, and so it's really unlikely that it's going to come in under my baseline. It's likely to continue to launch in such a way that it takes it somewhere between 1.7 and 1.9 seconds to run. And because the baseline is lower than the amount of time that this code is taking on average to run, this test should therefore fail. We can use a test like this in a situation where we want to ensure that a set of operations is happening with enough speed, especially the case if we want to make sure that a certain API, which has a whole bunch of functionality underneath it, remains fast even if we change that functionality. So now we've run the test again, and you can see that it fails, which is what this red X is telling us. You can also see that in the diagnostics at the gray diamond, we're seeing an average of 1.87 seconds launch time, with a baseline of 1.5 seconds. Now, this test only allows a max standard deviation of 10%, and the result that we got was 24.6% worse than what we were hoping for. So that's how we can use a performance test to ensure that things remain quick inside of our application.